So now we've figured out for 0, 30, 45, 60, and 90 degrees what all of these ratios are. Sine is 0 at 0 degrees. It's 1 over 2 at 30 degrees, root 2 over 2 at 45 degrees, root 3 over 2 at 60 degrees, and then 1 at 90 degrees. Cos is the exact inverse. It starts at 1, then goes to root 3 over 2, then goes to root 2 over 2, then goes to 1 over 2, and finally goes to 0. It works in the exact opposite order that sine does. Tan starts at 0, and then goes to root 3 over 3, then to 1, then to the square root of 3, and finally is undefined. It's always undefined for tan when it lands on the y-axis. So at 90 degrees, logically speaking, the same thing would happen at 270 degrees, so on and so forth. Even though it's not obviously evident, tangent ratios are always the exact same as the sine ratio divided by the cosine ratio. This will be important in the 30 level as well. Tan of theta is equal to sine of theta over cos of theta every single time. That means that based on the reference angle and what quadrant it exists in, I can state what the exact ratio is going to be, like what we were doing in the previous lessons. If I have sine of 210, that's going to exist in quadrant 3. In quadrant 3, sine is negative. I also know that my reference angle for 210 would be 210 minus 180, or 30 degrees. When sine is 30 degrees, like from our chart here, it's 1 over 2. I can say that sine of 210 is equal to exactly negative 1 over 2. And this one works out nicely because when I plug it into my calculator, it will tell me negative 0.5. So that's an easy, obvious one. The irrational ones are a little bit trickier. I'm going to do the same thing for cos of 300. At 300 degrees in quadrant 4, cos is positive. The reference angle is going to be 360 minus 300, or 60 degrees. When I look at 60 degrees, cos is 1 over 2. And I'm going to say that cos of 300 is equal to positive 1 over 2. That is the exact value. Last but not least, tan 225. That's going to be in quadrant 3, where tan is positive. The reference angle is going to be 225 minus 180, or 45 degrees. And I shouldn't even need to reference it. At 45 degrees, tan is exactly 1. So tan of 225 is going to be positive 1. Now, like it says up here, for the test, these units need to be memorized. You need to know these off the top of your head. The nice thing is that mostly they're not too hard to memorize. If I look at sine, it goes 0, 1, 2, 3, and up to 1. If I look at cos, it goes 1, 3, 2, 1, and down to 0. So the middle ones go 1, 2, 3, or 3, 2, 1. I could think of them all as square roots, right? The square root of 1 is just 1, so 1 or the square root of 1 would be the same, and those ones are all over 2. The trickier ones are the tan ones, but once again, not a lot of numbers to remember. How do we apply this? It says, without technology, determine the exact values of theta where cos of theta is equal to negative root 3 over 2. Well, at root 3 over 2, my reference angle, when cos is root 3 over 2, is exactly 30 degrees. Now, cos is negative in quadrants 2 and quadrants 3, where my rotation angle in quadrant 2 would be 180 plus my reference angle, or 210 degrees. In quadrant 3, my theta is going to be, oh, sorry, I did those backwards. This one's going to be minus, and that's going to give me 150. This one is going to be 180 plus 30 degrees, or 210 degrees. Theta is equal to 150 degrees, or 210 degrees. When it says that tan is undefined, we know that tan was only undefined at 90 degrees. If that's true, then that was in between quadrants 1 and 2, and in between quadrants 3 and 4 are the two times where the reference angle is 90 degrees. This one occurs at 90 degrees. This one occurs at 270 degrees, or straight up and straight down. My angle then could either be 90 degrees or 270 degrees. When it says that the point of -3 and the square root of 3 is on the terminal arm of the angle, without using technology, complete the following questions. Draw the angle in standard position and mark the point P. Well, we've done this before. X is negative, Y is positive. So that's going to be somewhere in here. There's my rotation angle, represented by theta. State the values of x, y, and based on that, the value of tan theta. Well, in this case, x is equal to -3, y is equal to the square root of 3, which means that tan of theta, which is y over x, is equal to -√3 over 3. When it says state the reference angle and hence the rotation angle, well, my reference angle, when tan is √3 over 3, is 30 degrees. It's the only time when tan is exactly √3 over 3. My rotation angle has a reference angle of 30 degrees and it ends in quadrant 2. It's going to be 180 minus 30. My rotation angle is exactly 150 degrees.